We are seeing a period of epic drought. The extremes are becoming more extreme. We have to plan for that because it affects all of us.
Today, TechKnow not only gets a satellite's view of California's epic drought from NASA's Jet Propulsion Lab,
We're the eye in the sky.
we also get a boots-on-the-ground perspective in the Central Valley where once fertile fields have gone to dust.
My parents were migrant farm workers. And then we established our family here in the early 50s, and that's where I grew up and learning a lot about farming, especially cantaloupes.
Growing fruits and vegetables has been Joe Del Bosque's life work. But this year, about a third of his fields will sit, unplanted and unproductive.
Our water comes from the U.S. Bureau of Reclamation, and they allocated zero water to us this year. So we did not have enough water to plant this field.
This is California's Central Valley, known as the world's food basket. These fertile lands feed the nation. California produces nearly half of America's fruits, nuts, and vegetables. But without water, these fertile fields become a dust bowl. And the impact is widely felt. With nearly 430,000 acres left unplanted and the loss of 17,000 jobs, the drought is costing California $2.2 billion. And for the nation, an increase in food prices for years to come.
And if it's a dry year, it will be a disaster that's never been seen before.
What are you going to do, Joe?
You know, it's scary to think about it.
Water doesn't always come naturally. Dry spells and droughts are common to this region. Bringing water here is an engineering feat. 20 reservoirs transport water from Northern California to the Central Valley through canals and pumping stations. Today, all of the major reservoirs are way below capacity. Shinny Samora went to one of them to see for herself.
The San Luis Reservoir is behind me. When it's 100% full, it's up to that water line just there. But as you can see, during this period of drought, it's only 20% full.
These images show just how depleted some of California's reservoirs are today. And these all-time low water levels can also be seen from space. So I paid a visit to NASA's Jet Propulsion Lab to learn how scientists are using new technology to track water availability.
Our computer models suggest, and the climate community agrees, we will be seeing more of this in the future, and not just in California, but across the whole southwestern United States. So more prolonged drought could become the new normal here.
Jay Familietti is a hydrologist and JPL's lead water scientist.
The space-based perspective is a really unique one in that you really get a holistic view of water storage and how it's been changing over time. One of the things that we've learned is that over the last 3 years, California has lost about 4 trillion gallons of water per year. To put that in perspective, that is more water than all 38 million people in California use each year.
What are you guys seeing with your satellites?
So we're seeing a few key things here in California. We see that the last wet season, last winter, was drier than most of the previous dry seasons.
Our wet seasons are so dry, they're worse than a dry season.
That's right.
That's
right.
unbelievable.
It is. It is.
Most of the western United States has been in drought for the last 15 years. But what California is experiencing is exceptional drought, the most intense categorization. JPL's GRACE satellite generates unprecedented data that not only backs what we see on the ground, but shows a dangerous tipping point.
Economically, what's that going to do to California?
Well, it's going to have a big impact on the agricultural industry, of course. We need water to grow food, and that will ripple through the economy of the United States.
NASA's other aerial mission is taking flight above the Sierra Nevada mountains, a vital source of California's water supply. And here, too, the news isn't good. Less snow in the winter means less water in the spring and summer. According to the California Department of Water Resources, the snowpack is at its lowest level since 1988.
So tell me, why is snow important?
So snow is really it's a critical resource.
Tom Painter is a snow scientist and director of JPL's Snow Optics Lab.
The main thing we're focused on right now is understanding the snow water equivalent.
How do you measure that?
We developed what's called the Airborne Snow Observatory, which is a combination of the spectrometer to measure how much sunlight is being absorbed by the snowpack, and a scanning LIDAR, which is like a high-frequency laser pointer, and it measures the snow depth. The instruments look out this hole in the belly of the plane. The snowpack is a reservoir of water. It snows up there, it stays up there until the spring, which is about the time that we're using it for agriculture, for municipal use. So there's this nice handoff of water, so water can come out of the reservoir and it can be backfilled by the snowmelt. And that information then is fed to water managers that gives them an idea of the forecast for the coming weeks.
And the forecast isn't good. The lack of significant snowfall is just one issue scientists must deal with. The other is man-made.
Dust and black carbon that's coming from industrialization and accelerates snowmelt in ways that we haven't understood previously.
Here at JPL's Snow Optics Lab, scientists collect snow samples and use a spectrometer to measure for levels of dust and black carbon.
Dust and black carbon are dramatically accelerating snowmelt.
So at the end of a mission that you guys do, you end up with a map like this. What am I looking at?
This map gives us an instantaneous snapshot of how much water there is in the basin and where it's located. Having this kind of information is key to optimizing that reservoir.
At the core of this mission's success is the computer technology developed to build maps and models of the snow water equivalent within 24 hours.
You guys are already changing the way water's managed.
Having the best possible information is critical to maintaining our economy, maintaining the agriculture, maintaining the municipalities.
But NASA scientists aren't just tracking water in our mountains. Their satellite images are also revealing groundwater depletion. When surface water from precipitation is scarce, desperate farmers start drilling for groundwater. Back in the Central Valley, Shinny met up with a team from the U.S. Geological Survey who are also keeping an eye on the shrinking aquifers.
Since I've been working in the Central Valley, I have not seen this many wells needing to be drilled or heard of this many wells going dry.
Claudia Font is a hydrologist with the USGS.
And as they pump the groundwater, the water levels drop, and this year with all the drought, they're lower than they've been in a long, long time.
So is it completely unrealistic to think of these deep-level aquifers as just an unlimited resource?
We are actually lowering the water levels, lower than their historic lows. We're taking more water out than we're recharging the system.
But there's an even more immediate impact of all this well digging: land subsidence.
Subsidence is the lowering of the land surface.
Michelle Sneed of the USGS tracks how much subsidence is occurring and where.
This is a canal. As subsidence occurs, the road lowers, the water's starting to run into part of the bridge, and it needs to be raised.
And actually the water is flowing this way, isn't it?
Right, the water's flowing this way, and that's why all of these items are sort of shoved up against the bridge, instead of flowing underneath the bridge if there was some space between the water surface and the bridge.
It's really unbelievable. You can see that.
But what's perhaps most alarming is that subsidence permanently changes an aquifer's ability to hold water.
So what happens is that aquifer system can hold less water than it did before subsidence, and that's forever. That is permanent.